Okay, so hopefully I don't have to introduce myself to you unless there are some Erasmus students on this program and I didn't receive any emails from anybody, so probably not. Um, okay, let's get straight into it. So I sent around the link to this website, same kind of style now as last semester. Right. This is the website, and I've given you the link to that. So I'll get straight into it and just look at the overview first, and then we'll get into the first topic, which is actually just a programming language. But let's talk about the module in general terms first. If you know anybody that was doing this module last semester or last year, sorry, it wasn't actually called Cloud App Development, it was called Distributed Systems. But I rebranded it last year um, to kind of reflect the kind of stuff that I like to do in the module. Sorry, give me another, gosh, give me another second. Sorry, wait a sec. I rebranded it to Cloud App Development, as I said, to reflect more accurately what I like to cover in this stuff. Um, right. I should have checked, but I forgot to check actually. You do a module in third year. Now, I don't know. I should have checked the exact name of it. The name I'm giving the module here is Cloud Computing Services. Can somebody tell me is that the name of the module that you did in third year where you looked at AWS, or was it called something else? Can you remember? See here where I've got what I'm trying to show here is the link between the module that we're about to do, Cloud App Development, and some stuff that you already know. There's a tentative enough link with Web App Dev 2, but I've got a narrow arrow here, whereas I've kind of got a
It was called Automated Cloud Services. I'm pretty
automated
sure.
cloud services. Okay, I got services right, I got cloud right.
Yeah.
Automated was so that's what I'm representing by this year. And so there's definitely a kind of a strong link with that in the sense that we dig a lot more into um, AWS, the AWS platform. So that's kind of the context for Cloud App Development. And because development is in the title, there's a lot of coding, much more than was in the DevOps module last semester. That module was more about configuration. And there's some of that as well in this, but we do it in an imperative programming language. We don't use kind of YAML as such. The first bullet point on this slide is taken directly from the module specification. Now, the module specification was written quite a long while ago, maybe 7 years ago, 8 years ago, and it was called Distributed Systems back then. Now, believe it or not, it's actually quite difficult for us to make changes to modules. We have to go through a whole kind of vetting process, and it's quite arduous. So, um, but kind of that aside, that's kind of our problem. But that aside, this is kind of this statement from the original specification that still holds in the sense that we're interested in looking at the architecture of, I'm saying, modern distributed. And when I use distributed here, I'm saying it's particularly referring to cloud-based and service-oriented. Now, arguably, the stuff that we did in DevOps had was interested in distributed systems as well, and service-oriented was part of it, and indeed cloud was as well. Even though, okay, we used just an in-house. cloud, I suppose, if you like, that Kubernetes cluster. But we could have just as well have configured a Kubernetes cluster up on AWS. So to a degree, there's some sort of a uh, I could have even put DevOps into that little image that I had on the previous screen, and there would be links with that. Um, so we're looking at the architecture, and when I talk about architecture here, sure, the containerized approach would come under the kind of the heading of architecture, but we're not looking at containers at all in this module. We're looking at like because there are many architectures that you could use for a, a distributed application stroke system in 2026, and if we just kind of skip forward, the two architectures that we're going to look at is the serverless architecture, and we're also going to look at the event-driven architecture. We'll look at the event-driven at the very end, actually, at the kind of last maybe a couple of weeks. Well, maybe longer than that, really. Maybe last third of the module, if not slightly more than that. So there are the two architectures that we're looking at in this module. And once we've done those two, then you kind of have three architecture styles um, uh, that you are aware of at that stage. The third being the kind of containerized architecture model. In this module, we are actually interested in designing and implementing uh, these architectures, but also we're interested in the whole deployment of our distributed applications and deployment in an automated way. That's going to be a significant part of this module as well. It's all well and good developing your application locally. You want to deploy it to the cloud. We don't like doing that in a manual way. We like to be able to automate it. And when we talk about automating the deployment, then we're talking about something called infrastructure as code, which is something that we look at very early on in this module. And once we have that technique, then we can start digging into this kind of serverless architecture style and the event-driven architecture style. Whenever you're talking about a distributed application that's deployed to remote servers, i.e. to the cloud, then scalability is always a concern. Will the application be able to deal with spikes in demand? Now, fortunately, the AWS platform takes care of a lot of the scalability issues for us, but we still need to be aware of what it's doing behind the scenes. And I'll refer to that uh, as we work our way through the two architectures. I'm just saying we're only looking at what I'm calling a constrained set of requirements. Our applications are going to be quite small, necessarily so, but still we'll have a good sense of the principles as a result of that. So that is kind of broken up. This is a kind of a detailed breakdown, if you like, of this sentence or part of a sentence that I got from the module specification. The module specification may not refer to, although I try to make some changes to it. It may refer to serverless and event-driven at this stage, but originally it didn't. It was more kind of generic, and there's nothing wrong with a generic module specification. So there's a lot of implementation, and for no particular reason, we're going to use TypeScript as our language. We could really have used anything, well, almost anything. We could have used Python, Java, could even use Kotlin, Rust. Any of those languages are supported by AWS in order to achieve all of these things, including infrastructure as code. So the code that we'll be writing is in JavaScript, and as well as the application code, we'll also be writing code that implements the creation of infrastructure up in the cloud. So that's the plan. I don't think there's anything here that you don't have already. Everybody has an AWS account from the DevOps module last semester. I did get you to create an AWS account as far as I can remember. And I'm I may not have said it then, but if the AWS account, well, sorry, the AWS account that you have has to be within the paid tier and not the free tier. Now, that's not to suggest that we're going to be incurring large costs in this module. We certainly won't be. But still, some of the services that we want to use are not available on the free tier. So put all that another way, if the account, the AWS account that you created last year, or you may have created prior to last year, if the account, the personal AWS account that you have is not on the paid tier, then you're going to have to create another account for yourself with a different email, and I'm not sure will it accept a different credit card or the same credit card. I'm not sure. You may have to delete your current account and recreate a new one. Either way, make sure it's on the paid tier. You need to install the AWS CLI, which I think we used a little bit last year. You certainly would have used it in the automated cloud services. So you need to have an installation of that. I don't really care what version of it that you have, as long as it's version 2.x. Node you have, VS Code you have, Git you have, GitHub account you have. That's all very good. So there's nothing really there. You do need to maybe refamiliarize yourself with the AWS Cloud Management Console. That's, have I logged into my AWS account? This management console that you would have played around with a lot in the automated cloud services. So you'll see me using that quite a lot actually as I demonstrate stuff to you. What's here? Okay, 2 lectures, 2 labs per week. Lectures will be online. Now, the labs are scheduled for Friday, but the labs, the style of labs in this module are very similar to the style in the DevOps module, which means really that you should be able to work your way through them without me having to kind of sit by you, if you like, or give you instructions or give you demonstrations at the beginning of the lab. So there is a room allocated for the labs this year. We'll see how it goes. I'll turn up to them initially, but if people are happy to just work away on their own on the labs, I have no problem with that. I certainly won't be taking attendance records or anything like that. Now, just on that point, unfortunately, I can't make the labs this week, and in fact, I won't be able to attend or give a lecture on Thursday of this week either. I'm actually not available on both days. So just to make you aware of that. The assignment structure
Could you
is,
repeat what you just said?
uh,
I heard it.
yeah,
It
sure,
broke up
yeah,
for a
sure.
second.
No problem. I'm saying that there is no lecture on Thursday of this week. And also I will not be able to attend the labs which are scheduled for Friday. I won't be able to
Okay.
attend them this week either. That's just a once off, unfortunately. The assessment is 100% CA, and you'll see actually it's structured the exact same way as I used in the DevOps module. That's all right. Actually, that URL is incorrect, but I gave you the URL of the website on Slack anyway. Moodle we only use for assignments. This is what the breakdown of topics that we covered in this module last year looked like. So start off with TypeScript, then we looked at something called the CDK, Cloud Development Kit, then we looked at the serverless architecture, then the event-driven architecture or message-oriented architecture. And we looked at full stack as well at the very end. That was literally one lecture or maybe 1.5 lectures. Okay, so that's that. Are there any questions just so far? No? Okay. The first thing we need to do is foundational. And by foundational, in the case of this module, is we need to have a quick crash course on the TypeScript language because that's what we're going to be using throughout. So if you know TypeScript already, good for you. But I'm just assuming, I'm assuming nobody is, but I am also assuming everybody is a very competent programmer and are very familiar with JavaScript. So the transition should be straightforward enough. I'm going to exit out of these slides. How is the Wi-Fi holding up on your side, I wonder?
It's going good now.
Okay. Fingers crossed. This GitHub repo you can access, and it will contain the code that I will be kind of using as demonstration as I work through these slides. So you may or may not find that useful to you. Essentially, TypeScript, okay, it's a superset of JavaScript. What does that really mean? TypeScript actually it's only a compile time language. You cannot kind of execute TypeScript. You have to compile it first, and it compiles to JavaScript, and that is what you run. It's JavaScript that you run. And that's something that many people who actually know quite a bit about TypeScript don't remember, I suppose, really, that it is only a compile time language. And clearly, it's really JavaScript with a data type system kind of layered on top of it. That's one way of kind of looking at it. Developed by the same guy that developed C Sharp and Turbo Pascal, so it's got really good credentials kind of from that perspective. Let me bring up my pen. This guy, Anders Hallsberg, if that's how you pronounce it. ECMAScript, as you know, is the specification for the JavaScript language. And what this guy did, Anders Hallsberg, was he looked at the version 4 and version 6 of the ECMAScript specification, and that's what he used as his basis for designing the TypeScript language. And there's some other kind of interesting quotes down here from people that are kind of well known in the whole web development kind of world, I suppose. So we needn't really start talking about those. TypeScript was really, where it really shines is where you've got a large code base, a large application that you want to develop, web-based application that you would normally develop in JavaScript. But because of the nature of JavaScript, which is that it is a dynamically typed language, and that has many benefits, but it also has many drawbacks. And it's for that reason that TypeScript came about at all, to make the developer's experience much better than would be the case with JavaScript, because JavaScript bugs are notoriously difficult to debug. And TypeScript kind of saves the developer by catching potential bugs at compile time rather than at runtime, as we'll see every now and again. GitHub do a survey every year of their repositories globally, and they produce a number of really interesting statistics. One of them is just on what are the most popular languages on the GitHub platform. And you can see on the graph there that for quite a long period, over a decade really, JavaScript was the most popular. And only last year, Python overtook it as being the most popular language, more than likely because of the emergence of AI. But TypeScript actually, and TypeScript of all the languages here, TypeScript is the youngest of them. Because if you follow its path here, it only really came about around 2016, but it did rise to being the third most popular language. That is as of December 2024. Now, what I do every year is I just check this. Sorry, as I said, the GitHub they produce this, they survey these, all of the repos, and they essentially produce a report. The report is called the Octoverse. You may have come across it, the Octoverse report. And so, like, just as a matter of interest, I checked the Octoverse report every year, and I checked it there last week. And lo and behold, what emerged from it was that around October, I think, or maybe September, October of last year, 2025, TypeScript actually jumped up to the number one position in on the GitHub platform, which most people were quite surprised with. They would have thought that Python would have retained its number one position. So, and they don't really give a solid reason as to why that's the case. But more generally, I think there is a shift away from dynamically typed languages to statically typed languages as part of the kind of AI movement. But I'm not suggesting for a minute now that TypeScript is heavily used in the AI world. It is to a degree, but certainly not as much as Python. And it may become more important in the AI space. We'll have to wait and see. But looks like TypeScript is something that would look good on your CV. Now, to get into the nuts and bolts of it, TypeScript source code files, we use the .ts extension. There are also TypeScript declaration files which have this extension, .d.ts. That's where we would define any custom types that are relevant to the particular application that we're developing. Now, you can put your custom types in your source code file as well, but just for slight better separation of concerns if you put any custom data type declarations into these declaration files. And these declaration files are actually used a lot by third-party JavaScript libraries, because, you know, when we're coding in TypeScript, the ecosystem clearly is not as mature as the JavaScript ecosystem. We'd like to be able to use all of the really good third-party JavaScript libraries in our TypeScript code. And we can do that, but of course, it's still JavaScript and it doesn't have any of the type safety features that we like in TypeScript. So what the maintainers of many, if not most, of the third-party JavaScript libraries that are out there, what they have done is added TypeScript declaration files to them so that we can avail of them in our IDEs and our editors. And you'll see that as I kind of demonstrate some code to you. But of course, we define our own TypeScript declaration files as well for our custom types. The TypeScript language has a primitive types obviously built into the language, and they're the ones that you would always expect. So these are the primitive data types that come with the TypeScript language. The undefined one clearly comes from JavaScript. Null is null part of JavaScript? I'm not sure. I think it might be. But the other ones then are the ones you expect. And every other data type in TypeScript essentially kind of inherits from the object type. The object type is part of JavaScript. So classes and modules and interfaces and all various other types are kind of inherit from this object type. And if I just flick to the next slide, this is the built-in type hierarchy that comes with the TypeScript language. So here we have our primitive data types, and they all inherit from a parent type called the any type. Kind of an unusual thing, but it's a real thing, okay? So you could actually declare a variable and you could say its type is the any type. Now, that would not be good TypeScript programming, but you can do it. Because if you declare a variable and you say its type can be the any type, then you're essentially saying I can assign any value, any type of value to that variable, which kind of defeats the whole purpose of TypeScript. TypeScript is statically typed, as is obvious, I guess, whereas JavaScript is dynamically typed. What does dynamically typed mean? It means that, when in JavaScript, when you declare a variable, on one line you can assign a number to it, on the next line you can assign a string to it, on the next line you can assign an object to it. Whereas on TypeScript, you cannot do that unless you have a variable and you say its type is the AnyType, in which case you're kind of falling back onto JavaScript. And you should never really do that. And every now and again, the compiler will tell you that you've got a variable and it's assuming it's of the AnyType, and you need to try and correct that. Over here, then we have the ones, the undefined type, the void type, which we will see actually. TypeScript also has typed arrays, something that you don't have in JavaScript. And way over here on the right is the object type. So that kind of comes from JavaScript, right? And if you define your own custom types, you're essentially kind of attaching them onto the object type, or their super type is the object type. Go back again to this one. So the AnyType, all types are, that's okay. That's okay as well. So from a syntax point of view, the first thing we need to know is how do we declare the type for a variable? And it involves using this postfix syntax. So here's a simple example. The let keyword, which we know from JavaScript, I'm declaring a variable called me. And here's the postfix syntax where I'm saying this variable, its type is string. So only string values can be assigned to this variable. If you try to assign another type of value to it, then the compiler will complain. So that's the postfix syntax. You have typed arrays. So here I'm declaring a variable, and the way you interpret this is to say that this variable is going to be an array of numbers. So the square bracket, close square bracket, that signifies an array type, and specifically an array of numbers in this case. There is another syntax for declaring an array, as we'll see, but the other syntax we don't use that often. Types also apply to function declarations, in that you need to declare the type for each parameter of a function, as you can see here, and you need to declare the return type. That's what is happening over here. I'm saying that the return type of this function is number. So that's type annotations. That's the syntax, this postfix syntax. You have classes in TypeScript, but of course, as you know, you have classes in JavaScript as well. And so really all TypeScript is doing is reusing the class syntax from JavaScript. I don't need to talk my way through this slide. I'm just showing you on the right the actual syntax in TypeScript and just some facts on the left. Interfaces are also available to us in TypeScript. Are they available in JavaScript? I'm not sure, actually. Should have checked that. Either way, we know what interfaces are from Java and other languages that you looked at. Again, I'm just showing you. I don't need to explain what interfaces are. And again, I'm just showing you the syntax of how you declare interfaces in TypeScript, and just some facts on the left. So, for example, in terms of facts, you can have interfaces can extend other interfaces. Classes implement interfaces, of course. And, classes can implement multiple interfaces and all that kind of stuff. As it turns out, we won't be writing many classes in this module. It'll mainly be kind of functions that we'll be writing. Now, something that is new is the notion of interface data types. It's unfortunate that they use the word interface as part of it. So there's a difference here now. An interface data type is essentially kind of a template for an object's that are going to be in your code base. So I'm saying here interface data type. It tells the TypeScript compiler about the shape of an object, object as you understand it from JavaScript. Yeah. And so an interface data types will tell the compiler about what are the various properties that make up this data type and what are the types of the values associated with those properties. Here's an example of an interface data type declaration. So the keyword interface, this is the name of the interface data type, and this is the shape of a person object in this case. So the syntax is the key name and the key type, and you do need the semicolon at the end. Yeah, so person looks like a two property data type where both properties happen to be strings. And here I'm declaring a variable of that type using my postfix syntax again. And the compiler will obviously check to make sure that you do have two properties called first and last, and the values assigned to those properties have to be strings. If any of those conditions don't apply or aren't adhered to, then the compiler will throw a compilation error. So that's interface data types. Let's switch over to the code samples. I lost a lot of time at the beginning, but anyway, can't do anything about that. So you have access to this code yourselves from my GitHub account. So if we look at basics index.tes, simple stuff going on here, declaring a string, declaring a number variable, playing around with them here. Now clearly, like if I uncomment this line, then the red squiggly line here is essentially a compilation error, and I'm getting a compilation error because I'm trying to assign a string to a variable that I have declared as being of type number. So the compiler is actually working behind the scenes as you are typing your code, as you're developing your code. And as well, initially anyway, certainly when you're using VS Code, if you want to find out what is the problem, even though it's fairly obvious here, then what you do is you select the Problems tab down at the bottom here in VS Code, and it will give you essentially kind of the compilation error. So it's saying type string is not assignable to type number, and that indeed is correct. I am trying to assign a string to a variable whose real type is number. Of course, as you know, in JavaScript, there's nothing wrong with that. You can do that, but may not make a whole lot of sense, really. Also, what else? Just some console logs, that's all right. That's okay. Oh yeah, well, the same kind of stuff is going on here. If I uncomment that line, I'm trying to invoke the toUpperCase method on a variable which is of type number. And again, the compiler is saying there is no toUpperCase. Now it doesn't call it a method, it calls it a property. You can see here, property toUpperCase does not exist on type number. Why it calls it property is a throwback to JavaScript, really, but I'm not going to go into it. We would know that that is really a method in our case. And again, I know I've probably said it already too many times, but you won't discover that you've got a silly kind of method invocation going on here in JavaScript. You won't realize that until you actually run the code, and it eventually throws an error, and then you have to go debugging it. Whereas with TypeScript, these kind of mistakes are caught at the pre-runtime, at the compilation time. As well as the primitive data types that come with TypeScript, there are some built-in types as well. I'm just showing you one of them here. There's a regex, regular expression, built-in type that comes with the language. And I'm just showing you how to use it there, just as an example, which you can look at yourselves. Just some examples of array types, array of numbers. We had that in the slides. This is the alternative syntax for declaring an array of things. The syntax that I've highlighted there now is what's called the generics syntax, which we'll come on to later on. So that is the exact same as just using the square brackets, but clearly there's less physical keyboard typing when you're using the square brackets. So that's what most people would use. And, if I uncomment this line, so I've got my array, which is an array of numbers, and here I'm trying to push a string onto that array, and I'm getting the red squiggly line. And the explanation is argument of type string is not assignable to parameter of type number, okay? Which is another way of saying you can't put a string you can't add a string entry into a numbers array. In JavaScript, there's no problem with that because it doesn't support typed arrays, not natively anyway. And again, this is being caught at compile time rather than at runtime. Interfaces. Are we on time? Slowly running out of time. So I've got a person here. Let's keep going to instance of person. Here I've got a student interface data type made up of an array of strings is one property. So this is as you can have your interface data types as kind of complex as you want to. This is an instance of a student. Here I've got a semester result interface data type. That's not very interesting. I've got a student exam profile, and you can see, some of the properties are referring to other interface data types here and here, and I've got an array of these things. So it's as powerful as you want it to be, and it really depends on what the nature of the data structures that you're dealing with in your particular problem domain are. But interface data types can handle anything. Let's see what's going on there. That's all okay. And again, the compiler, in terms of it working behind the scenes, if I uncomment this line, I'm getting the squiggly line here because there is no property called name associated with what? Associated with what is it associated with? Module. It should have been module name rather than name. Yeah, so it's catching that first. So it's always working behind the scenes. Type aliases, and I've kind of ran out of time really. No, I'm tempted to keep going, but I won't. Okay, we haven't gotten very far. If you're interested, there's a lab that comes with this, and you do actually need to submit this lab, but the lab clearly is going to run into next week, if not the beginning of the following week. But you could try and see how far you get with it. The lab is written in that kind of prescriptive way that my labs last week were written. So see how far you can get. Like we've only covered interface data types, so you should be able to do that section. We haven't covered functions or any of these things, so you may try and see how far you can get and do a bit of Googling to try and help you if you need help. But have a start at it anyway. As I said now again at the outset there, I won't be able to attend the lecture this Thursday. So our next lecture will be this time next week. I'll pause just in case there are any questions for
Uh,
me so far.
You said that we're going to upload the labs. There's no upload boxes on Moodle or anything yet. Will those
Oh,
just be added?
oh yeah, I need to add that, of course. Yeah. Yeah, I'll do that. But the submission time will be probably won't even be next week. It might be early the following week. So there's lots of time
Okay.
availability.
Thanks.
Good. Anything else? No? Okay. I'll talk to you next week in that case. Bye for now.